Hello, welcome back to Blend Sushi Live Noding. In this episode, I will be sharing something fractalicious. So basically, you can see here something that looks a little bit like a fractal. It looks like slightly hexagonal, and it looks a little bit like a snowflakes. Okay, let me scrub a little bit, and just play back while talking. So basically, this is around 1,500 result of iterations of something that's actually really simple. I found something on a post on Twitter. Basically, someone said, okay, you can try doing this. You start with a hexagonal. You start with a hexagon, and then you pick a random point inside the hexagon shape. From that point, you create an pick a random edge from the hexagon, and then connect the points so you get a triangle. And once you get the triangle, get the center points of the triangle, and then from that center point, you grab another random points from the hexagon edge, and then you connect it and you get another triangles, and then you repeat the process many times, and then after a while you're gonna start to get a pattern, which is basically I think it's hexagonal, but it's also the way the way it works underneath. Somehow the points inside the triangle things getting pulled by 6 different hexagon, and it start to get this kind of pattern. So if I fast forward, and you can see it's starting to get this kind of snowflake pattern. So from the I set up the whole things actually using SVerchok nodes. It's a little bit maybe not yet super efficient, but I'm gonna show it to you. This is something that you can create faster if you're using maybe Python, or maybe animation nodes, or maybe using script node. So basically this is my setup. Okay, so I have a bunch of things happening multiple times here, but here's how I started. I started with an n-gon 6-sided, so it's become hexagon, and I get a random points from this mesh, okay, from the face of the hexagon, just a single point, and then I'm joining it with this. What is this exactly? Here I have a way to pick a random edge from hexagon. So I have list shuffle, grab this edge data, shuffle it, and then just pick one. That's gonna be our random edge. I use delete loose because to clean up a little bit, so we only left with points of the edge that I can connect together with these random points. Then I'm using UV connections, and I should get a triangle. So that's my first triangle. At any time in point, I can randomize the points, and I can randomize also the edge that point is going to connect to. So let me give different colors. So that's actually the first. That's the first one. Oops. Yeah. Just randomize the seed. You can see that's the dots, and this is how the dots randomly placed. It's very interesting. So it's almost like if I keep randomizing this, it's almost like a robot kind of typing, making dots randomly. Okay, so what's the next step? I grab the center points of the triangles. I get that origins. I should probably make a visualization of that dots. So it's clear what's going on. So that's the center point of that triangle. So that triangle, that points become the next iterations. Here I actually have monads, right? This is the first version of the monads, and inside the monads is basically it's taking another n-gon. So I have the ability to change the side of the n-gon if I want, but I keep it hexagonal, and then get this, the center points of the triangle will be the point that goes into this process. Inside the process is the same process happening again. So I'm gonna do this over and over and over again. So this is the first setup, not very efficient, but this makes sense here when the process is happening and then the result of the previous process is passed on into the next process. So almost like recursive iterations, almost. But the way I then change it, so I change the monad, keep it simple. So inside the monad now, I already have the hexagon. So outside, it's only taking the origin or the center point of the triangle, and then using that point to select random edges and then get the center point of that triangle. So the process is now happening inside the monad. And this is SVerchok Monads, right? It's slightly different from animation nodes. I think animation nodes can be a little bit more robust and complicated, but SVerchok has its own thing. So it says, so basically here we have a monad, and you can see the green nodes. There is this loop index. So that's loop index referring to this number. Okay. So this number actually is not just simply doing simple things. Actually, it's taking this origin and then processing it 28 times or whatever n numbers we have here. So we might process it like 100 times, 1,000 times, or 10,000 times, and the output of every iteration is different. What's missing here, I think, is the ability to output multiple results. So I did actually make the fractal things like if we actually start from 0 and then you go up one by one, you can see the points starting to emerge. Maybe I should also make this bigger. So this point is it seems random, but if you actually cache it, if you bake on every frame and then export it out as an icosphere, you will get what I showed you earlier. This is the final result. This is the fractal thing that I was talking about. In fact, if you keep going, perhaps you're gonna end up with a lot of dots that's actually smaller. It's all gonna be the same like this, but it's actually smaller and smaller. You can see there's already hexagonal patterns emerging. So this is quite interesting. It's something that's seemingly random with a little bit of recipe, and if you repeat the process over and over again, you start to get some kind of art. It's very unusual, I think. So it's like a lot of things in life. Maybe you might think you are randomly learning something, but in the end you eventually create something that's perhaps more beautiful, more or less. But yeah, you need to have some kind of constraint. So this is actually quite interesting. I don't know if I get it right, but because our constraint is hexagonal, that's why we get a smaller hexagonal pattern, and there's some kind of, so the rules and the constraint actually make it beautiful. Otherwise we have like chaos, right? We need a bit of rule or constraint to hold the ideas. So yeah, there you go. I think it's maybe my first understanding of fractal, because I'm not a coder really. I'm just doing a lot of node stuff. But yeah, I think anyways, the setup, like if you really want to, yeah, if you want to make this better, you can use the script node of SVerchok, SNL Script Node Lite, and make a code that basically doing these iterations. And for every iteration that's happening, you try to cache create a list. So instead of, so these points is not the random points, like I said. This goes around, goes and until it creates the fractal pattern. But the thing with the monad, if you put 10,000, if you put big number here, it's actually trying to process it. This thing is actually pretty fast. So I might need to ask SVerchok developer, maybe we actually have a way to output and cache the result of this. You know, see, this is doing 10,000 processing and we get a result here, which is actually based on the previous 999 process that's happening before it, but we don't have the cache. That's why I export it out using the obj, and then that's why we have that pattern. So anyway, that's the whole story. Hopefully this is useful and interesting. Let me know what you think, and I'll see you next time. Thank you. Bye.